uh, what happens that it is not like it is starting means the whole blood 5 liters of blood is dumping in the heart. It is not like that. Partially some of it is traveling in your body, some of it is getting purified in the lungs, some is still in heart, some it is going back, some part of it is coming over there. So that is how the whole thing is balanced. So see to this that uh, how these atria and auricles and ventricles are uh, collecting them and distributing it to the whole body. So first, as we know that these walls that are present between the auricles and the ventricles. Okay, so these walls are basically as in the beginning we must have studied that walls of the ventricles are very much thick. So basically they have these types of wavy thickness you can see in the wall of ventricles, and through these muscular thickness muscle fibers will be arising, and they are holding these walls uh, just to keep them and just to keep them tight whenever there is a requirement, and relaxing thing that they are providing. So just the way you are having that spokes in your umbrella, and when you open it they just become stiffed and tightened up, and when you just close it they just bend and they give the proper shape for closing of the umbrella. Similarly that type of mechanism is happening, and these fibers which are arising, they are basically called cordae tendinae. So these chorda tendinas are coming up from these lower muscular region of these ventricles, and they are holding these flaps. So now what happens that whenever the circulation is going on inside in the heart, so basically the whole blood that is deoxygenated blood, basically if we say uh, uh, that which consists of CO2 and all that. So the whole blood is collected through these vena cava, and it is dumped into these right auricles. At the same time, what is happening on the left auricle, that the oxygenated blood from the lungs is getting collected, and it is filling up these left auricles. So just imagine this situation that both the auricles are working at same time. It is not like that the first this thing will be done on this side, then the whole purification will be done, then the on this side these auricle, this particular auricle will be start working. Both the auricles are working simultaneously, and both the ventricles are working simultaneously. So what is happening over here, that here deoxygenated blood is getting collected, and here oxygenated blood is getting collected over here. Okay. So this is how the circulation will be done, and so part by part we will be studying, so so that you can have the clear idea regarding the purification of the blood. So whatever deoxygenated blood is filled over here, uh, uh, once it is filled, then these flaps will be open, and it you can say, because these are empty, so vacuum is being created, and that is the reason that as the blood is collected over here, it will be filling these ventricles slowly. Automatically they will be filled up, and once the filling of the right ventricle is done, then these flaps will close again. They will not allow the blood to go in the right auricle in any circumstances. And after that, because no other opening is there for the movement of blood, and ventricles are pressing themselves, they are creating a pressure, so blood will be entering in these openings. And this particular opening of pulmonary artery will collect the blood, and it is also guided by the flaps or the valves. They are just the pocket, you have the pocket similar type of structure is there. So uh, they will just open up like this, and the blood will be going inside this, and in one shot it will move in this particular channel, and then the flaps will get closed again, so that the blood should not come down to these ventricles. So once the blood is here, it will go and divide for both of the lungs. In the lungs, definitely this pulmonary artery will be dividing into arterioles and capillaries, and these capillaries will be dumping the deoxygenated blood. Basically, not dumping, because capillaries will be carrying this deoxygenated blood, and because of the structure of capillaries, they can diffuse CO2 and O2 easily. So as lung is already prepared with oxygen, so what these lungs will do, they will just take up the CO2, and they will just add oxygen to the blood, and again the capillaries and everything will be covering, capillaries will be collecting it, and then it will be collected by these blood vessels, and it is dumped into the left auricles. So this is how the purification will be done for the blood. That means deoxygenated blood will be converted into the oxygenated one. And once it is coming over here, similar mechanism will be done for the ventricle. Then again, this aorta will be collecting this oxygenated one, and it will start distributing the blood to all over the means the whole body will be getting this oxygenated blood with this particular channel. So, as you have got the idea that same blood is entering the heart twice. First in the deoxygenated form, and second the oxygenated form. So that's why this process is called double circulation. Understood this?
Yes, ma'am.
Okay. So this is how the double circulation. That means same category of the blood is traveling in the heart twice. So if we say that for proper channel, if we write, just prepare the flow chart regarding this. So with the superior and inferior vena cava, we can write it like this, that superior and inferior vena cava are collecting the blood from all over the body, which goes to right auricle. Then right auricle is giving it to pulmonary artery. Then pulmonary artery gives it to the lungs. Then lungs are giving this particular blood to the pulmonary veins. So these pulmonary veins are collecting it. These veins are giving the blood to the left uh, auricle. So I missed it. Ventricles. So right auricle to right ventricle, then right ventricle to pulmonary artery. So left auricle will be giving it to left ventricle, and similarly then to aorta. Aorta will be giving the blood to the body parts, and through body parts it will be again coming back to the vena cava. So just a simple flow chart is there. The passage of the blood, if you on means uh, peripherally, if you want to read the blood flow, this is how you can define it. So this much thing, uh, whatever is going on in this particular thing, that is called pulmonary blood flow, because it is involving lungs. So you have two types of names for the blood flow, because double circulation you are writing. So just if you are dividing it, so this much portion, because it is involving the lungs and all that, so this is called pulmonary flow. And while the one which is involving the other tissues are called systemic blood flow. Okay. So this is how the double circulation can be subcategorized into pulmonary and systemic. Understood this?
Yes, ma'am, understood.
Okay. So I think it's a easy, because it's not a complex thing. So this is how,
No,
yeah. So this is how the things are going on, and uh, uh, the whole every part right now, whatever the heart is doing, it is completely the mechanical thing which we have seen. So the way the machine is working, so similar type of thing is happening in the heart right now, due to the pressure created, whatever the pressure is there, due to the pressure the blood is flowing, and that is the mechanical part of the heart we have seen. So now see the electrical concept of the heart, because there is a electrical side also. So if we say that regarding the electrical issue of the heart, let's see to use that, we will talk about the pacemaker, because you require a little bit of spark in the heart. Otherwise, only the mechanical thing will not be working, and it requires a little bit of electrical energy, and a small amount of current is produced in the cardiac tissue, and that is produced by the natural pacemaker which is already present in your heart. So basically what happens that if we divide heart like this, and somewhere in the near the opening of vena cava, you have a collection of the cardiac tissue which is modified like this, just the way you have the moles on the skin. Similarly, that type of very much uh, if we say the complex collection of the cardiac tissue is getting there, and that particular tissue is called node. So sino auricular node is the name. So this particular node is acting as a pacemaker. It's a natural cardiac tissue. No, just the way your automobiles, your vehicles are having that starter. I think in engines it is there. The one which is when you are kicking the to start your means scooter or something like that. At that time you need some a small tube structure that is called, which is producing the spark. Am I right regarding the machine?
yes, ma'am, it's
Okay.
required.
It is required. You have a starter which creates a spark, and that burns the fuel, and that gives the energy, and that's why your vehicle starts. Similarly, these type of the thing, these sino-auricular node is there. It is what it is doing is that this particular tissue is responsible for producing generation of the current, and now see this, there is a septum. The septum, that means division, is there, which is dividing auricles and ventricles. In that also, you have one nodal tissue like this. So that is called AV node. auriculoventricular node. You can write like this. So AV node is there. Now what happens that whatever spark is being produced, the way we require earthing in our home, whatever the whole circuit is going on inside our home, uh, we have at one point the earthing is there, so whatever the extra current or whatever the current flow, it has to be grounded under the earth. So similar type of thing is there. Now this AV node is having the nervous tissue like division inside these particular septum, and somewhere here also in the ventricles. These are the ventricles. Divide. Okay. So these particular fibers are having the division like this. Just understand. Okay. So what happens that whatever the current is produced by this particular sino-auricular node, the current will flow in this direction. The waves of the current will be produced, and once the wave is touching, because this is the fatty layer is present, so it is acting as a bed conductor. So only this AV node is the one which can receive the current whatever is produced by the sino-auricular node. Are you getting what I'm saying?
Yes, ma'am.
Okay, because here it is
That is a bad
covered by
con-
the fatty tissue. So means good cholesterol, if you say, so that is covering this particular layer. So here the current will be, it's like because it's a bad conductor, nothing will happen. But AV node is like an open plug, and that will receive the whole current. So whatever current is being received by this AV node, that has to collected by these fibers, and these fibers are basically they are called Purkinje fibers, and the branches of it is called bundle of Hess. Okay, so this is how they will be just allow the current to travel through these walls of the ventricles, and due to this production of the current, the contraction for the muscular layers, that means these ventricles will be little bit easy, and these production of current makes the heart to beat. If you have gone through the facts like that, after the death also the heart is beating for 8 to 10 hours. Have you read this?
No, miss, first time I have heard this. After death, how
Okay.
can the art means?
Yeah, if you take out the heart from person's body, it will not stop working at one moment only,
Miss,
because
but when a person dies, the doctor checks his pulse in his hand, and if it is not present, he says na that he's dead.
yeah, that pulse rate is definitely is not there, but it this is not giving you the pulse is created by the pressure of the blood. Okay, but the presence of current is still there, which makes the heart to work out little bit. These tissue will be moving, and they will be helping the heart to keep up for 8 to 10 hours. That's why transplant becomes easy.
Okay, ma'am.
Okay, so the pulse, that's why I will be coming up to the pulse and that part. Pulse is created by something that is called blood pressure, and that is created mechanically. Understood? It is nothing to do have with the electrical part of this. So so basically, this keeps the heart uh, a continuous movement to the tissue is given by these pacemakers. So I think artificial pacemakers, you must have heard, many of the people who are suffering
Yes, ma'am.
from the these particular problem, they have artificial pacemakers, and just the way you have the hard disk, similar type of equipment is there, which is always there in their pockets. So it will keep the whole record, that how these artificial pacemaker is working, and once the batteries are out, you can change them and again it will start working. So this is how the artificial pacemakers are nowadays. Now the technology is too good. It's not previously it was there a big um, just like a brick, like thin brick like hard disk was there, which the person has to keep that in their pockets for the whole life. But now it is constructed in a size and it's good. It's lighter in weight, and many of the things are better. So this is how the pacemaker will be working for the
Ma'am,
production of the current in the cardiac patient.
yes, ma'am. Ma'am, to replace the batteries, we need to operate.
No, no, no. It's not like operating, because you have something that I said na hard disk, like through that only you can do the changes, and it will start working.
Okay, ma'am.
Okay. And it's a very small operation nowadays. It is done within few hours only. It does, I think it's too much advanced. It doesn't take too much of time nowadays. So this is how the pacemakers are being placed. Because sometimes in some of the person this happens that this particular node will become dysfunctional, but rest of the heart is completely healthy. So at that time you have to replace it with the artificial one.
Okay, misunderstood.
Okay, so that is how it will be doing up. Now let's go to the again the mechanical and that part, because you asked me regarding the pulse rate and all that. So we will be doing this systole and diastole, that means contraction and the relaxation part, and how our heartbeat is formed, and why the sounds of the heartbeat is coming up. I think two sounds you must have heard. When you put the somebody's other's heart, if you must have heard it, at that time you can hear that two mixture of two sounds are there. So let's talk about systole and diastole. Okay, so systole and diastole are the two phases in which the one heartbeat. Yeah, let me show you one diagram. Have with me. Okay. So first of all, let me say that as we know that heartbeat stays for zero point 0.8 to 0.85 seconds is the division. You can zero point 0.8 to 0.85 seconds is the time for the whole heartbeat, one heartbeat. So so you can see that yeah, that's why you have a average of 72 to 75 beats per minute, I think. And it changes with the situations, it changes with the even male and female, it changes with the person's physical profession also. So uh, the number can be anything, but it maintains these type of particular range to complete the one heartbeat. Now see this, I am showing you a diagram on the one side. I was just teaching class 12, that's why I have it. So here what is happening? I have just drawn the one part of the heart. So can you see these arrows which are giving here? They are showing you the contraction. So what is happening at this time? The systole means contraction. First of all, understand that. So when the auricle is contracting, just hold on. Okay, so here, as the contraction is proceeding and the blood is going towards the ventricles, can you see these this particular channel? That means the walls are open and ventricles are relaxing and they are filling up it with blood, and it is this part is contracting. Okay, now this particular thing, when it is happening at the after that, uh, this situation is will be there, that the ventricles are completely filled, and this particular means atrium, if you see, it is going the whole contraction is done, it is completely finished, and can you see that walls are closed? Okay, so because this is deoxygenated blood right now, so this part has to be closed, and it will be these eight on the left side, if it is happening, it is filling up with the oxygenated blood again, and at the same time the ventricular walls will start contracting. So just see to this, that the contraction starts from the tip of the ventricles. Basically, it is not like that it is squeezing out from anywhere to provide the contraction. So this particular contraction starts from this side, and that is the reason that current is helping out over here. So it will start from this tip, and once this is done, the contraction is spreaded all over the ventricle, and the blood will start moving through this particular channel of the blood vessel. Understood? So
Yes, ma'am.
this particular situation stays for almost 0.1 second, okay, or 0.15 second. Some books say it must be like that. So that much time will be taken by this particular part. Then a 0.3 seconds almost is done for both of these situation. It will take 0.3 seconds. Okay, so this is the time when the AB walls pressure, here what happens that uh, whenever there is a closing and opening of the walls, so that at that time first sound of the heartbeat will be coming up, that is lub sound, if you say. So at that time, uh, because AB walls closes, and that produces the sound, that is first sound of your heartbeat. Is it clear to you?
Yes, ma'am.
Okay, so this is actually the whole contraction part, total systole, if you say. So this is how it is occurring. Then you are having the whole diastole one. So you can see that well, as the ventricles is diastoling, and the walls are here also, that onset of the wall will be there, there will be closing and opening will be there. So second sound will also be there, that is called dub sound, from the heart will be coming up, and here the complete ventricular diastole will be there when the blood is filled, and you can see the auricles are also relaxed. So that whole situation will take zero point 0.4 seconds. Now see to this, that how these particular contraction and relaxation goes on. So what happens that first of all the auricle contraction will be there, and ventricle will be relaxed. Then ventricle will be contracting, and after that both of them are relaxed. Is it clear to you?
Yes, ma'am.
Okay.
It's clear.
So contraction, that means systole, diastole. Then little bit of systole, then diastole. Is it clear to you?
Yes, ma'am.
Okay, so this is how the 0.8 second is being divided. Basically, actually, according to your book, as I have seen, there are so many things, words I cannot use for you right now, because it will give you lot of dimensions according to the text. So I'm just making you understand that systole is regarding the contraction and diastole is relaxation, and how it is happening with the auricles and ventricles. That part you have to understand. So uh, at first sound that is coming, it is because of the AV valves closes down. That's why the lub sound is coming. And just remember that when the ventricle diastole is going on, semilunar valves are closing down. That's why the second sound is coming up. Understood this?
Yes, ma'am. The sound is due to the closure of the valve.
Valves, yeah. And that is the reason that particular sound will be, because they are just like flaps. So what happens that whenever they pushes themselves towards means for closing, just the way the door makes the sound, similar type of sound will be developed by these uh, valves. Understood this?
Yes, ma'am. Understood.
Okay, so that type, because there may be the questions like that first sound is coming up due to the closure of which type of valves. At that time, you should remember that first sound is coming due to the AV valves, they are closing. And second sound is due to the semilunar. That means in the aorta, one aorta is having the valves. Due to the closure of that particular valve, second sound is coming up.
Yes, ma'am.
Okay, so that part you have to remember, and that is how the whole heartbeat is constructed. uh, uh, Actually, the whole if you see the whole channel, uh, this particular pacemaker and all that, uh, you must have seen ECG for some people if they are going through this particular procedure of having the electrocardiogram. Have you seen that graph like paper is there, and in that the whole uh, graph is drawn with so many means that type of graph is there in which you can see something like this.
Means it can be. I have not seen.
Okay, on I think on television you must have seen that type of thing is there. So if you see the paper of the ECG, it is just like the graph paper you are having in for drawing in practicals like physics, and in that practicals you
Yes,
have
ma'am.
some of the graph papers. Okay, so that type of paper is there, and that ECG is calculating the functioning of your pacemaker basically. So that decides that the whole electric part is working clearly or not. And this electrical and mechanical function of the heart are connected somewhere due to these fibers and all that. That part is that's why they are helping out in contraction and relaxation very easily. But you don't have to go much in detail regarding this right now. Just understand that all these are involved for the smooth mechanism, and the contraction of the ventricles and all these are taking place because of the production of the current by the pacemakers and all
Okay, 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 ma'am.
that. Okay, so this is how it is done. Now see that as we talk about the pulse rate, and we should take up with this that blood pressure also. Okay, so pulse rate is nothing like something which you are calculating something different. It is almost similar to your heartbeat. The only thing is that you are calculating the pulse rate at the different part of your body, not directly from the heart you are calculating. So you can calculate somewhere in near your wrist also, somewhere near your vision also. At that portion you can feel it very clearly. So it is because the when as we have seen the circulation, that whenever the blood is being shot from these ventricles and it is going to the arteries, at that time the arteries will be having feeling that pressure. So that pressure is uh, uh, considered as a pulse rate which you are feeling at your wrist or somewhere else. Understood this?
Yes, ma'am.
Okay. So because these blood vessels, arteries are receiving blood with a lot of pressure at that time. And you know that arteries are very much deep inside, situated in deep inside our body tissue. So still you can feel that pressure with a little bit of beating somewhere near the pulse. And there is a difference that whenever you are having a fever or some emotional distress or something like that, at that time that pulse rate will be differing. That's why doctors checks out your pulse rate first of all whenever you are having a fever. Okay. So what happens that actually the blood pressure here is very important, because we know that blood pressure, whenever there is a systolic and diastolic pressure, if we use the word, okay, so the systolic pressure and diastolic pressure is there. So systolic means the range should be nearby somewhere 100 to 140 is there. Okay. So this should be the range. And for diastolic, it is somewhere 60 to 90 is there. Or basically 80, 80 or 85 also you may take. So that is what the diastolic pressure. This much means I think you know that there is a calculation of pressure with the help of unit, and that involves the HGMM. This is how the unit has to be written. Have you?
Yes, ma'am. MHG.
Yeah. So and it, because the meter which is calculating it, that sphygmometer, is having the mercury inside, and that's why that type of thing unit is there. So this systolic pressure and diastolic pressure, in common language, if you hear the people that uh, uh, the upper pressure or the lower pressure, you must have heard upar wala niche
Yes,
wala,
ma'am.
that's why they say. Okay. So basically 100 to 140 is the range where you can classify the person as a normal one. And 60 to 80 or 85 is completely normal, nothing is very much you have to worry. But if this range is not being followed, at that that may lead to the uh, situation like high blood pressure or low blood pressure. That means if it goes below 100, and diastolic pressure goes below 60, then the person is suffering from the low blood pressure. And if it is going shooting up more than 140, and more than means even 90 is sometimes damaging to your heart. So if those people who are not having a good health, if they are suffering from diabetes or some other ailments, so there may be the possibility that little bit of change in the pressure can lead to the severity in their physical conditions. So you must have seen those who are having the high blood pressure, they suddenly become anxious and start sweating. Sometimes they start shouting also. Okay. So due to the, and if they become little bit aggressive, then also their blood pressure will shoot up. So high blood pressure is not good, because what happens that at that time your heart, suppose if it is applying pressure like this, suddenly it will apply pressure like this in the blood vessels. So that may lead to the damage of the many of the tissues which are carrying the blood. Is it clear to you?
Yes, ma'am. It's clear.
Okay. So that's why it should not be done. And low blood pressure is also not good, because you are not receiving the blood in the way it should be gone through to your body parts. And that's the reason the people who are suffering from low blood pressure, they will be just without energy, they will feel like that they are just falling down or crushing down, and they will just lie down on the bed, and they cannot even open their eyes. So that's why the low pressure is not good. So high blood pressure will definitely give you the extra energy, and low will take up your energy. That's how you can find out, spot the difference. So this is how the pressure is responsible for creating the pulse rate. Okay, and pulse rate is just equivalent to the heartbeat, because now understand this, that pacemaker is responsible for the working of heart. Okay, and the pulse rate you felt somewhere on the other part of the body, it is because of the arteries are having the blood with the pressure. That's why you are feeling that beating. So here that current is not responsible for giving you that pulse rate. Is it clear to you?
Yes, ma'am.
Okay, so this is how the whole combination of this particular system is there, and uh, this is how the whole blood flow and everything will be working on. Let me see to this if anything is regarding this is there or not. I am just referring to class 12th, class 11th also, basically. In class 11th, it is there. Because there are so many things which your book is giving us to study. So,
Yes.
okay, fine. Yeah, one thing also that I want to show you, that you were asking me that regarding the blood clotting part. Okay, so I have simplified it for class 11th. I will just show you that you have the idea that it's not only the thrombin and prothrombin part. Okay, it is something like that. This is how the factors are working. Can you see this?
Yes, ma'am. Intrinsic and extrinsic.
Yeah, there are two types of things are working on, and there are so many factors, and they all I have just numbered them. They all of them are having their names, and everything is there.
Okay, ma'am.
Okay, I just want to show you that this is how the whole cycle is there. This cascade is there. It
It's
is
too
not,
long.
yeah, it's too long, and you have scientific names and you have common names also for these particular factors. So just hopefully, if you are planning to be a doctor, then definitely we will be doing this.
Yes, ma'am.
So this is how it is done. Then just with this, let's talk about the structure of arteries and veins, basically the blood vessels, if we say. So blood vessels, if we consider, we have arteries, we have veins, we have capillaries. Okay. So if we see to the structure of these blood vessels, three major layers are there, which are making up the structure of these particular blood vessels. So see to this, first of all, arteries, veins, and capillaries, if we say, uh, all they have, I will be drawing and will be showing to you first. Take colors, let me take up. Mm. So you have arteries with a if I am from the inner side, if I am starting, this is a artery, and it is having a layer which is just uh, gives it a internal circumference or diameter, if we say. Okay, then this inner layer of the artery is lined by a endothelial tissue. Okay, so this endothelial tissue is called tunica interna. Okay. So tunica interna is the one made up of endothelial tissue basically. Now see to this that after that, because arteries are somewhat little bit thicker in nature, so they have another layer of the tissue and it is quite muscular and thick. So here the muscles are there. This is called tunica media. Okay. So this particular layer is made up of smooth muscles and basically the yellow elastic fibers. Okay. So these two types of tissues are present in this. Then you have the outer layer which is giving the covering to this particular structure, and that is called tunica externa is there. Okay, so it is a connective tissue, epithelial and mixture of epithelial and connective tissue is there, which gives the strength to the arteries and holds the whole particular vessel in a very uh, congested form in the particular our body. So this is how the arteries are there. Now we will compare the veins with this. You will get the idea that what's the difference between this particular veins and arteries. So basically the this area here, the passage is called lumen. Okay, that is a passage. So basically the difference is regarding the passage only. So veins are having comparatively bigger lumen if we consider them with arteries. So this particular veins, if we say, definitely they will be having this particular interna will be there. Then you will be having the media. Okay, and then you will be having the external. Can you just see uh, the section I am drawing? Can you spot the difference?
Yes, ma'am, I can spot it's very thin. The layers are very
Yeah,
thin.
layers are comparatively
They're
thin
very
as
close.
compared to, yeah, very close. So that's what the layers are same. Everything, the construction, that means the material they are for the construction of them they have used. Everything is same. Just the basic difference that lumen is bit larger as compared to the arteries, and here the layers are too thick as compared to this one. So that is what the difference between veins and arteries, if we say. So this is how you can label them easily. They're easy to make, first of all. So this is how this is lumen is there. Okay. So that is what regarding the veins is there. And if we talk about the capillaries, so they are much more simpler. Okay, so this is the this is how it will be there. So there will not be any type of media basically over here. So directly they will be having the external. Understood this?
Yes, misunderstood.
Okay, so this is how the difference between veins and capillaries and arteries is there. And uh, because of absence of this particular media layer in this, the capillaries are bit elastic in nature, and they can just uh, dilate it themselves and contract themselves very easily according to the situation, according to the blood flow. So that's why there, if there is a little bit of difference in the pressure suddenly, nothing will be happening to these particular capillaries because they are too much elastic. And due to the absence of that muscular layer, they can easily squeeze out the leukocytes through their surface. Okay, whenever it is required, requirement of leukocytes is there in the body tissue, so they will easily squeeze them out, and they will just the way the diffusion occurs, similarly the leukocytes will go out of their surface easily. So that's why these capillaries are like this. So capillaries undergoes vasoconstriction and vasodilation uh, type of condition. I think you must have seen that if you walk in sun, those who are very much of fair skin, you can spot that very clearly that their face becomes
They go red.
suddenly red.
Yes, ma'am. They go red.
Uh, yeah, and because of blood flow, change in the temperature is there, so blood flow will be there, that you can see. And if it's too cold, they will become bluish, and that
Yeah,
is
it's
the
due to vasoconstriction.
yeah. So that type of condition occurs for them, and so those who are old and those who are very much having the thin skin, on that you can find out that you can see a very thin lining very easily.
Yes, miss.
Okay,
Spotting the blood
so
vessel.
yeah, they can, you can spot them very easily. So that's how these capillaries are very much uh, means adjustable according to the temperature and pressure and all that. And there may be the possibility sometimes they even burst also. You must have seen that bursting of capillaries is there in the eyes of the person. Some people have a very red eye type of problem. They are having that always their eyes are red or something like that. There may be the possibility that their capillaries are bursting due to the external pressure. So at that time, doctors suggest them some of the drugs and all that, so that they can avoid that type of situation.
Yes, ma'am.
Okay, so this is how the structure of these particular blood vessel is there. Um, I think if this is done, then you have the hepatic portal system is there. That topic is there,
Yes,
and
ma'am. This chapter is too long.
yeah, it's too long, and I think a little bit of part is bit extra. You don't have to. I one diagram is there in which you have to just learn the names of the blood vessels which are going towards the kidney, or that part is there. I think it is there.
Yes, ma'am, it is there because in our council, the syllabus has said that all the blood vessels entering the kidney, liver, they are important. They have to be learned.
Yeah, that is definitely very important, but they are important when you are planning MBBS. Otherwise, they are not. But
The
uh,
council has said question will come.
yeah, questions can come from anything. Okay, but no problem. I will just guide you first of all, because I think that part is important when you are planning for NEET or something like that. So at class 10 level, I don't think so. Nobody is going to ask from my view, it is like that. But still, we will not leave it like this. So
So ICSE all chapters are much means extra as compared to CBSE board.
yeah, that is too much extra is there, and uh, because definitely that gives you the good platform, because the students coming from ICSE, when they are coming to the class 11th and 12th, it is easier
They
for
have
us to teach them because they have that background, not like the CBSE students, because for them we have to create a nursery, then
all these
LKG,
things
then
again.
UKG. That is happening. But for you people, it is that makes easy for us. But teaching you in 10th standard makes difficult for us, because we cannot teach you everything, and there are lot many things are involved in your books. So let's see to this, that first of all we will discuss regarding hepatic portal system. Okay, So just basically hepatic means something regarding the liver you are talking about. Okay, so this type of portal system is very important basically. Why is it so? Because all the veins from in our body, they are just running and they are going to the inferior vena cava or superior vena cava directly. Means they have the direct connection through the body organs. Only the hepatic portal system is something which is not doing such type of passage. What happens that veins from basically the stomach and the intestine, uh, stomach and intestine, that means capillaries arising from them, and these capillaries are turning themselves into veins. So what happens that these capillaries, these veins which are arising from stomach and intestine, they are just unite and means these types of veins come and unite and they will give you one channel, and that channel is called hepatic portal vein basically. Okay. Now this hepatic portal vein will be again dividing, means it will break down into the capillaries, and then again then they will form a new vein, means it will break down into capillaries in the liver, and after that they will again combine to form one major vein that is called hepatic vein is there. So dividing into capillaries, lot many capillaries will be there. Then another one singular vein is formed. This vein is now going to the vena cava. Vena cava. Okay, so it's not like that the veins from the stomach and intestine and liver will directly dump themselves into the vena cava. So what they will do, they will follow this channel. So what happens that this particular system, because it is starting from capillaries, and because when it is coming to vena cava, then again it is dividing into capillaries. So starting from capillaries, ending with the capillaries. That's why that is called hepatic portal system. In short, if you just want to understand. Okay. So portal means it's a port where everything is combining, and then again dividing and distribution is going on. Then again it is fusing to form a one channel and dividing into capillaries to go to the main blood vessel that is called vena cava. So that's what the hepatic portal system is there. That's how it is being constructed. Understood this?
Yes, ma'am.
Okay. So just remember that starting from capillaries, ending into capillaries. That's why hepatic portal system name is given. Okay. Now, regarding if we say um, with this, because actually when we have to teach the portal system, you have the lymphatic system with this, because you have lymphatic organs, and through that parallelly the lymph vessels are also running. So that is not mentioned the way it should be, but still I'm trying that to make it clear. And the thing is regarding the blood vessels which are coming from kidney and the liver, that you have to understand. Just see to that beta, that diagram which is given regarding one human bag flash is there in the background, and in that the whole diagram is there. Just I want to say that mug it up right now, because the thing is uh, every name, it whatever is written regarding arteries and veins, it has its own meaning. So the thing is because you have to just learn the names according to your syllabus. So
Which part? Can you repeat, please?
yes, dear.
Which part, ma'am? Are you talking about? Can you please repeat once?
That diagram that in which it is written that blood vessels from liver and all that is there.
Okay, ma'am.
Okay, and
Those
so you
renal
have to
artery and
just,
those.
yes, you have to just remember the names of the blood vessels. That is what is
Okay.
written with the your syllabus. So I will suggest you to just uh, remember it, just mug it up or do something and remember it, because if I because every that blood vessel has its meaning in its name. Why is it called mesenteric, why it is called carotid, why it is called jugular? That type of, I think, labeling must be there.
Yes, ma'am, they are.
Okay, so subclavian and all of them have their meaning in their names, and their meanings will make you understand that where are they going, what they are doing. But as according to your syllabus, you don't have to learn that much. You have to just remember the names. So just learn that diagram, learn the names of the veins and the arteries, all the blood vessels, and just go through them peripherally, I think, according to me, because if in detail I can't teach you right now. uh, it will take too long and it becomes out of context according to your syllabus.
Okay, ma'am.
Okay, so just remember that any of the blood vessel is having the hepatic as a prefix. It is, you are talking about something that is called liver. And if it has a renal, that means it, you are talking about kidney.
Kidney.
Okay, so that part I will make clear to you. Then I think on upper side, upper half of your body, that must be mentioned, that carotid is there, then subclavian is there,
Subclavian. Yes, ma'am.
then jugular is there. That type of names are subclavian, that means going to shoulders and all that. That's how it is there. But that's why I'm not going in much detail
Okay,
regarding
ma'am.
their positions. Okay, and mesentery on the lower side, mesentery is very much important. Then mesenteric artery is something which is dividing with your will give the division of the middle of part of your body, and that is dividing into that thighs, and where it is reaching. So just read this diagram, have a map of that diagram in your mind, and just remember that where they are. Basically, if any of the question will be coming to you, that will definitely with respect to the diagram only they will give from according to my view, because as it is
Yes, ma'am. From
suggesting.
diagram only they can give.
Yes, yes. Nothing else they will ask more. And so that part you have to see. Um, and if anything which question arises, just let me know. We will discuss that part, and I will give you the explanation, whatever we require.
Okay, ma'am. But that part where that artery and arteriole, venuole, that part, if you just could means explain once, then it would be of
Yeah,
help.
yeah, yeah. That I will be taking up. That first of all, as we say, that artery is the major blood vessel. Okay, and artery, when it is subdividing, it is called arteriole. Okay, and arteriole are dividing into capillaries. Okay, now these capillaries are again basically there is one diagram that one of the part is carrying the deoxygenated one and the oxygenated part. Red and blue diagram must be there. So
Yes, ma'am.
okay, so these capillaries are again combining with the capillaries, and these capillaries are coming up from the venules, and these venules are making up nothing but the veins. So this is how they are connected. This type of junction will be there. So capillaries and capillaries are in contact with each other. None of the blood vessel will be coming directly, only the capillaries will be in the picture. one which is carrying the deoxygenated one, the one which is carrying the oxygenated blood. Okay, so both of them will be in contact, and after that the broader channel they are creating, that is called venules, and for here it is called arteriole. And then the main blood vessel that been created by the combination of these particular channels, they are called artery and veins.
Okay, ma'am. Thank you.
Okay, what the idea?
Yes, ma'am.
Okay, so this is how it is being done. Now as we have this particular thing, that is lymphatic system, I think it's there still remaining.
Yes, ma'am. That's the last part.
Yeah, lymphatic is there, and little bit regarding the functions of the blood in the introduction part is, it is little bit we have not discussed yet.
Oh, ma'am. I think that is not in syllabus, that function part.
Because I think, but from my school they will be giving you for test. I'm giving you that only right now. That in my school they have decided to conduct a objective test
Subjective.
for you people, and it will be coming in this month. And I will just show it to you, that this is how the division of the chapter is being done. So just see to this, that first objective test will be conducted. In that you have the chapters from 1 to 7, and 16th chapter will be there. 16th is pollution.
The 16th chapter is which one?
I think pollution is there.
This pollution is excluded from our reduced syllabus. That three last chapters, pollution, and then population, and all these chapters.
Yeah, I know that, but actually, the management has said that whatever is being excluded after the finish, once your syllabus is done, we will be discussing this parts, these things also.
So what's there to discuss in pollution?
Just you
No,
don't have to
population is
worry.
okay. That's
Yeah, but this is how they are dividing beta. But so see to this,
1 to
that you
7.
just note down that first objective test will be having, that means cell structure of chromosome, genetics, absorption by roots, transpiration, photosynthesis,
Photosynthesis.
chemical coordination, and pollution.
Means chemical coordination is also excluded.
Yeah, I know that is being excluded, but it is being
How can I do
involved.
the test? I have not studied that chapter.
Yeah, I know it. Just do one thing, that I will inform the management.
I think I should call once the man who handles all these things there.
You can do that. You can ask them that we have some of the excluded chapters already. You are loaded with so many
Yeah.
things. Okay, you can just ask them. And next half is divided with that is circulatory, excretory, nervous, sense organ, endocrine, reproductive, human evolution, and population.
Okay, ma'am.
Okay, that is how the division is being done. But I already I have informed them that we are still struggling with the syllabus. So the omitted part of the chapters is uh, like it will take time to
We have still left endocrine and excretory, I think, ma'am, and reproductive also.
yeah, 3 chapters are there. That's why we have to I'm planning, let's see how much we can do.
Have they means told that we need to complete it by December only?
According to the thing, they have told me we have to complete the things in first week only. Okay.
First week.
So yeah. So I
This
have
is
told,
impossible.
yeah, that is impossible, because no matter
First
I
week of
attend,
January is possible.
no, first week of December. Okay.
Yes,
So
let's see.
Fine. So no worries. We are trying as much we can do. Uh, I am continuous contact with the management. I will let them know whatever we have done, what not is finished. That will also be informed. But still, I will say that whenever there will be a test, uh, let them come up with the thing that is not being done by us. You know the chapters we have finished. You just focus on that first of all.
Okay, ma'am. No problem.
Okay, so nothing to worry regarding that. So first of all, whatever we have done, you just be thorough with that, and let's see what how far we can go with this.
Okay, ma'am. Thank you.
Okay. So just so next we shall we go for the excretory system. I think that part we will be starting.
Okay, ma'am. I think endocrine was small chapters, means a smaller chapter than excretory.
Okay, the smaller one, but it's endocrine and reproductive will be almost same beta. The things
Okay, ma'am. Then we
we
will do
discussed.
together.
Yeah, yeah. So that we will be doing simultaneously, and so next we will be starting with the excretion.
Okay, ma'am.
Okay. Or meanwhile, in the weekends, if I will be able to do something, we will have the class.
Okay, ma'am.
Okay. So let's see. And this these tests will be in this month only. Okay.
Okay, ma'am.
Okay. So all the best for that, and have a good day.
Thank you, ma'am. Same to you.
Yeah.